Hi friends, welcome to the Unit 3, Day 3 notes. This one talks about a function defined by the polynomial that has the zeros, in this case -3, -2, and 5. So that means that if it's a 0, that means that when I plug this number back into this equation, that for one of the values I'm plugging it into, I should get 0. And that's a good way to approach it when you're trying to solve or figure out what values you need to plug in. So here, generally it's the opposite sign for when you plug it in. That's not always true. So for this one, if I multiply these together, if I take x plus 3 times x plus 2, I get x squared plus 3x plus 2x plus 6 times x minus 5. I'm going to go ahead and just combine all these. I get x squared plus 5x plus 6. Then I multiply that times x minus 5. For this one, I'm going to use the table method of multiplication. So I have x squared, and then 5x, and then 6, and then multiplying it with x and -5. So x squared times x is x cubed. X squared times -5 is -5x squared. That's 5x squared. 5x times -5 is -25x. 6x, and then -30. When I combine these, if you notice that because of these are descending and I have one of each power degree, same here, that these diagonals combine nicely. So I get for my final result the polynomial x cubed. Now these two canceled out completely. And then I have minus 19x if I combine those two together, and then minus 3. So that's my polynomial that satisfies these conditions of those zeros. B is a little bit trickier because what we have is we have a multiplicity. So remember, when we have a multiplicity, what I have here for this one is x minus 4, but because it's a multiplicity of 2, it's going to be squared. So that takes care of the first part. Now the other tricky thing about this is that it has an imaginary number, and we know from what we talked about earlier that it has a conjugate, and the conjugate, the opposite of the imaginary part, is also a 0. So then the other one is going to be 1 minus I squared of 2. Notice I just included the opposite sign of the imaginary part. Just the imaginary, not the 1. The 1 is going to stay as is. Now, this part confuses students, because essentially what I want to do is I want to plug in whatever, when I plug in 1 plus I squared of 2, I want that to cancel out or become 0. So I have to think, what's the opposite of both of these terms? The opposite of 1 is minus 1, and the opposite of a positive is a negative I square root of 2. And that's a good way to approach it. Same with this one here. I'm going to have x, and then opposite of a 1 is a negative 1, and then opposite of the negative I is a plus I square root of 2. Now this looks intimidating when we multiply, but in fact I know that when we multiply this together, when we multiply a complex conjugate, we get rid of the imaginary component. So when we multiply these two together, we should get rid of the imaginary part. That's the way that we want to approach this problem first, is by multiplying these two together before we multiply that. I'm going to use the table method again. So for this one, I'm going to use this spot over here. So I have x, -1, and then negative I square root of 2, and then multiplying it with x, -1, and then plus I square root of 2. So now I have my rows and columns, multiplying, put that there. X times x is x squared, x times -1 is negative x, and then here I have I square root of 2 times x, negative x here, positive 1 here. I'm going to go ahead and put the sign, it'll help me later. And then this is minus I square root of 2. Here I have minus I square root of 2x. This I have plus I square root of 2. Then here, this last square gets quite tricky because you have negative I times I, which is negative I squared. And then you have square root of 2 times square root of 2, which is square root of 4. Now this simplifies quite nicely, actually. Remember, negative I squared, well, I squared is -1, so I have negative of a -1, which is just a positive 1. Square root of 4 is 2, so this is just positive 2. So this part here, let's talk about all the things that cancel. The I square root of 2x cancels with this I square root of 2x. I minus, so they're opposite signs. Same goes on here with this piece and this piece. This I squared, remember, turned into a real number, and so now we're just left with, for this part, let's go ahead and bring down the x minus 4 quantity squared. This is x squared minus 2x, because I have two x's there, and then plus 3. This is a very common polynomial that we use to introduce, in fact, the idea of imaginary numbers. Now if I multiply through x minus 4 squared, I get x squared minus 8x plus 16. Then I need to multiply that by x squared minus 2x plus 3. Again, I'm going to use the table method. So I have x squared, negative 8x, 16. And I have x squared minus 2x, and then 3. That's x to the 4th, negative 2x cubed, 3x squared, negative 8x cubed, positive 16x squared. Let's see, that's 24, negative 24x, excuse me. 16x squared, negative 32x, and then 16 times 3 is 48. 48, there we go. Now I can just combine like terms. So my polynomial in this case is going to be x to the 4th minus 10x cubed. All of these combined together, 32, 35, plus 35x squared, minus 56x, and then plus 48. That's my polynomial. Whew, it's a little bit dicey, but we did it. And you notice that we have x to the 4th, 1, 2, because multiplicity of 2, 3, 4 zeros. So it satisfies the zero theorem. So we're going to use the rational zeros theorem next to write this polynomial in completely factored form. When we're given a polynomial and that's it, and there's a little bit more that we need to do to find all of the zeros, using the zero theorem that we talked about previously, and we'll go over that in the next video. Have a good day.